Alright, so according to the proportion theorem, a line drawn parallel to one side of a triangle cuts the other two sides so as to divide them in the same proportion. Now, with this theorem, the first thing, if you want to do the proof, okay, you have to be given that a line inside a triangle is parallel to the third side, like that. Okay, so you'll be required to prove that AD over DB is equal to AE over EC. Okay, now it's important for you to know that what you are required to prove this, it comes from the concept of triangle geometry, which I spoke about on Friday. Okay, you don't have to memorize this. So the basic idea is that the numerator, the lengths in the numerator, this AD here and that AE, they belong to the same triangle. Okay? So your AD and AE, they belong to triangle ADE. Then DB and EC, they are also related, okay, by the fact that you have to create two triangles between DE and BC, such that those two triangles will share the same base, and because they will be drawn between two parallel lines, they'll have the same height. That's how you end up having this DB and that EC. Furthermore, this AD and that AE, they will be bases of two triangles. So you have to choose two heights. Okay, in this case, we have to name the heights separately. One we call it K, the other one we name it as H. But it's important for you to know that this AD here and that AE, they are bases of triangle ADE. They are two separate bases. So you choose and say, okay, let AE be the base, therefore there has to be a height which you draw from AE to D. If you choose AD as your base, then you have to draw a height from AD to E. Okay? You must do it with understanding. Okay, so first thing, you have to choose triangle ADE first. Okay? And then you draw a height H, which is relative to AD. So in triangle ADE, you choose AD, then you draw a height from AD to E. Okay? Then you also do the same with regard to AE as well. You choose AE, then you draw a height from AE and you call that K. Furthermore, you have to join B to E and join C to D. Okay, please be aware that DE will be parallel to BC. Once you choose your two bases in triangle ADE, in this case it will be AD, okay, you must draw a height from AD to E. Then you also choose AE and draw a height from AE to D. Furthermore, you need to join B to E and D to C. Once you do that, you also have to go as far as, now if you want to get this numerator, that is AD over DB, right? AD, it's a base. DB, it's also a base. So what that means is you have to choose two triangles that share the same base, right? So they share the same height rather. So those two triangles are going to be ABE, that's the first triangle, right? The second triangle is going to be, please do me a favor, just hold on in terms of copy. I need you to pay attention to what I'm doing here. And then the second triangle is going to be ADE. So those two triangles, they share a common vertex, and that vertex is vertex E. So based on what I said on Friday, if two triangles share a common vertex, it therefore means they have the same height. Therefore, the ratio of their areas will be equal to the ratio of their bases. So this AD over DB, it comes from the fact that triangle ADE and triangle ABE share a common vertex, therefore they have the same height, and that height is going to be h. So if I write an area of triangle ADE, it's going to be half times AD times h, because h is our height. And then the area of triangle BDE, that is BDE, is going to be half times BD times h. Now the two halves cancel out, the two h's also cancel out, you're left with AD over BD. Okay, so that's the first ratio. Then the one on the right hand side, that is AE over EC. Again, we choose two triangles that share the same height. In this case, it's going to be height K rather. So it's going to be triangle AGC. Okay, so it will be triangle ADC and obviously triangle ADE. So triangle ADE is going to be a common triangle that you use to determine both ratios, right? So if you consider triangle ADC and triangle ADE, they share a common vertex, and that vertex is going to be HD. Therefore, both of them, their height is going to be K. So the area of ADE, it has changed now. It's going to be half times AE times K. The area will still remain the same. The only thing is that the base has changed, the height has changed. Okay? So it's going to be AE. Then for CED, that is CED, the area is going to be half times EC times K. Okay, please take note here. It's going to be CED, which is this small one here. Let me try. This is the triangle, that is CED, that triangle there. Right, so you end up having AE over EC. Again, because triangle ADE and triangle CED, they share a common vertex, it means their height will be the same, therefore the ratio of their areas will be equivalent to the ratio of their bases. Now, you also have to do some kind of elimination. Now, we know that triangle CED and triangle BDE are drawn between two lines that are parallel. Therefore, their areas are equal because they share a common base. They have the same height because they are drawn between two lines that are parallel. Okay. Therefore, the area of ADE divided by the area of BD. So here we replace this CED by the area of BDE because of the fact that their areas are the same. Now, if we do that, we can equate that to, in this case, because the area of triangle ADE is common, okay, we divide it by the area of CED. Then you come up with that ratio now. AD over BD is equal to AE over EC. And then you are done. Okay, so here it's like you are equating now this to that. Yes.
For the last step, instead of writing the area of triangle ADE, you write AD. And then on the right hand side, you substitute in AE. Why do you substitute in different things if it's the same value?
Which part?
So the top is area ADE, and then area ADE, but in the next one it's AD, AE. Why do you use different sides?
Okay, it's very simple here. I'm sure you can see that the numerator is common, right? The denominators, though there are two triangles that are different, but their areas are what? Are the same. So it's more like this. It's more like if you say x over y, this will be equal to x over z, but y is equal to what? To z. Therefore, if the denominators are equal and the numerator is the same, it means these two ratios are equivalent.
Okay, so you're not like substituting in anything. You're
No,
just equating.
you are just equating. You see, because triangle BDE and triangle CED, they have the same area, right? Which means that this and that are going to be equivalent. Are you following that? Hey, can you pay attention? Pay attention. Because the denominators, okay, these two triangles, that is CED and BDE, they are drawn between two lines that are parallel, which means they have the same area. What that means is, if the numerator is the same and the denominators are equivalent, we can equate those ratios. Okay, and then we'll come to this. So in an examination, you are expected to know how to do this proof, and you have to do it with understanding. And from my experience of having taught this for many years, a lot of learners, they don't understand what's happening. But I have tried to make it as simple as possible. Yes?
I just have one question. So AD and BD are both bases, right? So how do you know which, like you're using BD?
AD and what?
AD and BD are both bases.
Yes.
So how do you know you're using those two triangles down there?
Okay, look at first, if you want, remember this ratio here is based on the basis of the two triangles. So if you divide a ratio, or rather, if you divide two bases, what that means is that initially they have the same height. Okay, therefore, the only way that I can be able to determine this is by identifying two triangles that share a common what? Vertex. If they share a common vertex, it therefore means that the ratio of their areas will be equal to the ratio of their bases. So in this diagram here, you have to choose B, D, E, and A, D, E. Vertex E is common. Therefore, they share a common height, which is going to be H. Okay? If they share a common height, it means the ratio of their areas will be equal to the ratio of their bases. Then, for the second ratio, you also choose CED and ADE. They share a common height, which is going to be K. Now, normally, like in this case here, AD and BD, they belong to the same straight line, or they are part of the same straight line, that is AB. We can say points A, D, B, they are collinear, remember from grade 10? And also A, E, C, they are collinear as well, from grade 10.
Wait is that?
Right? Once you get this now, we can come to what are called corollaries, okay, in geometry. Now, a corollary is just a statement which follows or it results from another proved statement. So since we have proved this, we can come up with 4 corollaries, which means we can also say, therefore, AB over AD is equal to AC over AE. So that will be AB over AD is also equal to AC over AE. Also, BD over DA is equal to CE over EA. And then you can also have AB over DB equal to AC over EC. And again, BD over BA is equal to CE over CA. Now, when it comes to the reason now, can I have your attention here? Can I have your attention? When you use the proportion theorem, the reason that you must give, okay, there are 2. Okay, it's your choice to decide which one you like. Right? You can give it as line parallel to one side of triangle. Every time use the proportion theorem. So if you write this ratio, in brackets you must put line parallel to one side of the triangle. You can also write it as proportion theorem. Please, I'm just using shortcut here. Then you need to state the lines that are parallel, and then state the parallel lines. Okay? So there are 2 ways. Right? You can decide which one you prefer. nobody should tell you that you must write it this way. I'm not going to tell you. You can decide which way you prefer, because both of them are acceptable. Yes?
If you use the first one, you don't have to name the lines.
No, you don't have to name the lines. Okay, if you use the first one, there's no need to state the lines. But if you use the second one, you can't just write proportion theorem and then you stop there. You have to state the lines that are parallel. Page 10.
Oh, yes.
Okay. Now, before I move on, I also need just to mention that there is also a converse of the proportion theorem. So the converse says if a line cuts two sides of a triangle proportionally, then that line is parallel to the third side, right? Now, the reason for this, just write line divides sides of a triangle proportionally. Now, you only need the converse if you are asked to prove that two lines are parallel, okay? The proof is not examinable, so I'm not going to talk about the proof. You just have to know the converse itself and the reason, the statement of the converse and the reason. And you use it when you want to prove that two lines are parallel. Okay, please just copy theorem 1 converse, that paragraph and the reason, and then we stop there. Okay, the rest of the stuff you can reread on your own. Huh? You're introduced to the midpoint theorem. Okay, so if a line is drawn in such a way that it joins the two midpoints of the two sides of a triangle, you can conclude that therefore the line is parallel to the third side and is equal to half the third side. So we did that in grade 10. So this is the famous midpoint theorem. That's the diagram. So if a line bisects two sides of a triangle, you can conclude that therefore that line is parallel to the third side and it's also half of the third side. So this is the famous midpoint theorem. Yes.
Is there any relationship between the areas of the triangle AD and the quadrilateral DBC?
Maybe I've never done that group, but probably it is. But the relation which I know, which is this here, is the area of triangle ADE and ABC. They have a relationship. Midpoint theorem. Yeah. So the reason for this one here, you just write what? Midpoint theorem. Okay, that's your reason. So whenever you see a diagram whereby two sides of a triangle are bisected, the reason you can give there is the midpoint theorem. I think I need to make a copy of the acceptable reasons for geometry. Okay. Yeah, I'm going to make a copy of the acceptable reasons so that you can paste them in your maths workbook. All right, and then the converse. The converse. Okay, the converse of the midpoint theorem. Now, with the converse now, only one side will be indicated as having been bisected, but the line which bisects it to be indicated that it is parallel to the third side. Okay, so one side will be bisected, the other one will not be bisected. Also, you'll be given the two lines that are parallel to each other.
So the midpoint AD has over AD and AE has over AC.
Yes.
Both sides have.
Yes. Right, I'm going to, can I have your attention? I'm going to upload a copy of the latest examination guidelines. All right, just hold on.
So can you please check uploading? Please check if it's openable.
Can I check what?
Please check if it's like openable.
Yeah, but you see, that's not my fault. I suspect that the portal itself has got issues. All right. Can you have one lesson? Can you have one lesson, please? Right, with the converse, okay, you must be given one side of a triangle which is bisected by a line inside the triangle, and that line has to be parallel to the third side. So among the, in fact, in this case, it means that only one side of a triangle will be bisected, the other two will not be bisected. It's unlike in the original in the original midpoint theorem where two sides are bisected by the line inside. So in this case, only one side will be bisected. And your reason that you have to give for this is line through midpoint parallel to second side. That's the reason for the so-called converse. Okay. So before you start answering any questions on the proportion theorem, you have to know your proportion theorem, your midpoint theorem. Also, you have to know your converse of the midpoint theorem. Right? Okay, please just copy this down so that we can start doing some questions on the proportion theorem. Where is my Majola? Is she here? No, it's not like you are proving it. You are not proving. A theorem is just like a statement. Yeah. Okay, can I carry on? Right, we have 10 minutes. Can I have your attention? I'm going to use the 10 minutes just to show you an example of how to apply this. Then I'm going to give you homework after that. Okay, now can I have your attention? Your platinum maths, okay, in terms of the questions on this topic, it has got some very good questions. So I'm going to be using both the 2 textbooks plus past examination questions as well. So this question here is from your platinum maths, right? Okay, according to the question, this is the first question under exercise 3. Can we have one lesson, please? So you are given this triangle, and it's stated that FE is parallel to DC and DE is parallel to BC. Then you are given the length of AF, the length of GF, the length of AE. Now, if you want to apply or use the proportion theorem, always identify a triangle that has got 2 lines that are parallel. Identify the triangle first. So here it says determine with reasons the length of EC. So if you look at the diagram carefully, EC is from here all the way up to there. And I'm sure you can agree with me by observation that EC is going to belong to triangle ADC. So I'm going to apply the proportion theorem in triangle ADC. Okay? So I'm going to do it there. So first, you state the triangle. So in triangle AB, it's what? It's ADC or ACD. Let me write it as ACD. In triangle ACD, if I want to calculate the length of EC, there is more than one way of doing it. Okay, since I'm given AE, I'm given AF, and I'm given FG, I'm going to use our normal proportion theorem. So I can write this as AF over FD is equal to AE over EC. Okay? Once you write this ratio here, your reason has to be, you write as line parallel to one side of triangle. If you don't want that, if you don't like that one, then you can write here proportion theorem. Please, you only give one reason. I'm only writing it because I'm a teacher. Proportion theorem.
So which one will you be using?
I prefer the first one. Proportion theorem, then you have to state now the 2 lines that are parallel. So it's going to be FE is parallel to DC. So FE is parallel to DC. Okay? Then, after writing the ratio, the rest is very simple. AF is 4. Okay, let me use a different color to make it more clear. So, we're going to have 4 divided by, now, my FG is 6, my AE is 8, and EC is the one we want to calculate. Now, if you cross multiply here, you will get EC being equal to 8 times 6 divided by 4. And that will give you 48 over 4, which is a 12. So that will be 12 centimeters. Okay, so this is very straightforward. Very easy and very straightforward. Then, the second one, now, please be aware that we could also have written this as AD, okay, using the corollaries as well. AD over AF will be equal to AC over AE. So you could calculate AC first, then you do a subtraction. You subtract 8 from the length of AC. It's not the only way, there are several ways based on the corollaries as well. Are you following that? Right. But for this question, the easiest was just use the normal proportion theorem. Right? Then the next question now, the length of AB. AB, that's the length there. Now, to determine the length of AB, you have to identify a new triangle. And that new triangle is going to be ABC. The good thing, we know what EC is. Okay? So if you want to calculate AB, I'm going to use one of the corollaries to determine the length of AB. Okay? By the way, if I say corollaries, I'm referring to any of these 4. Okay? I'm referring to any of those 4 ratios. Okay. Your homework, can I have your attention? Your homework, you do 1.2 and then I'll give you, and then you also do question 2 from Platinum Maths. That's your homework. You do 1.2, then you also do question 2 in Platinum Maths.
So where can we find this question?